Okay, we're jumping right into Unit 3, and we're going to start out with Lesson 3.1, which is over dilations and scale factors. And hopefully this is a review from you because I know you worked with dilations and scale factors in at least junior high. Keep on giving me your section number and your course number with all communication. I don't have a course number typed on here. It needs to be included. That just means you need to put 202B, section 1, 2, 3, or 4. Okay, let's look here at what our objectives in this lesson are. We're going to define dilation, center of dilation, and scale factor. We're going to determine whether a dilation is an expansion or a contraction on the basis of its scale factor. And then we're going to sketch images of dilations, given the center of dilation and the scale factor. Here are the terms that we're going to be defining in addition to the ones we said, which I think all we have left is contraction and expansion. But we'll be defining these as we go through the lesson. What is a ratio? Let you think about that for about 2 seconds. It's a comparison of two values and can be written as a fraction, a decimal, or even an integer. And here's just an example that I put up for LMS. It says for two quantities, A and B, all of the following are true. A ratio may be written as a fraction, like right here, A over B. This is what it looks like as a ratio. We always put the colon in there, it means going to A to B. Or you could just write it out as a sentence, A to B. All right. Then they give you some other information here. It says the ratio A over B is greater than 1 if A is bigger than B. This is some basic fraction information. The ratio A over B is less than 1 if A is smaller than B. So A over B would be like 5 over 3. That's greater than 1. This would be 1 over 2. That's going to be less than 1. And then the ratio A over B equals 1 if A equals B, and that would be like saying 4 over 4. Okay, now let's talk about what is a dilation. We learned a little bit about dilations in, I think, Unit 1, Unit 2, or maybe it was in the fall semester. Because I'm teaching the fall class right now, and I'm getting them all confused who learned what. But it's a transformation. And remember, you have 4 kinds of transformations. You have a reflection, a rotation, a translation, and a dilation. And a dilation is the only one that is not isometric. Maybe you remember that from the fall semester. And look here, transformations that change the size but not the shape of a figure. So if you've got a big circle and you dilate it, it could become a real big circle or a really small circle. It's always a circle. It just changes its size. Okay, what is the center of dilation? The lines connecting each point on the pre-image with its corresponding point on the image intersect at a point called the center of dilation. The center of dilation can lie on, inside, or outside the figure. And all that might sound a little confusing, but we're going to see some pictures here in a little bit that'll help make it more clear. And last but not least, what is a scale factor? The scale factor of a dilation is the ratio of the length of a side on the image to the length of its corresponding side on the pre-image. And again, we're going to see some examples. Now let's look at what is expansion and contraction. If the image is larger than the pre-image, then the dilation is an expansion. That means it's getting way bigger. Okay? So the scale factor has to be greater than 1 for it to be an expansion. And if the image is smaller than the pre-image, then the dilation is a contraction. So that means that the scale LMS, they give you this handy little table. If the scale factor has an absolute value greater than 1, then it's larger. And look here, this is really going to help you where it says it's on the same side of the center as the dilation as the preimage. If it's less than 1, then it's going, the image is smaller and on the same side as the preimage. So on both of these, if it's positive, it's going to be on the same side. Greater than 1 is larger, less than 1 is smaller. Okay, now watch what happens if it's negative. Your absolute value is still larger, your absolute value is still smaller, but if it's greater than 1 and negative, it's going to be on the opposite side of the center of dilation. If it's smaller than 1, the image is smaller and on the opposite side of the preimage. So if it's negative, it's going to be on the opposite side. Okay? And you're going to understand once we start working with some examples. I wanted to show you some Geodura. Okay, let's look at this right quick. Remember, if the absolute value is greater than 1, okay, and it's positive, let's look here. Let's see what we're doing. See how the scale factor A equals 2.6 is getting larger and larger. And see as it gets larger, here's your preimage right here. Okay, that's your preimage. This is your midimage right over here. So watch this. As it gets larger, it moves further and further away. Okay? Now watch this as it gets smaller. And I like this right here, where I make it equal. Well, I just can't get it there to where it equals 1. It just pops back and forth past 1. If it was 1, it would be laying right on top of it. Anyway, watch this. Oh, notice how the scale factor is less than 1. Look how close it is to the preimage. Okay, now watch this. As we get negative. Look at when it's negative. This is what you see right here is our center of dilation. So as it becomes a negative scale factor, it's on the opposite side of the center of dilation. See? And the absolute value of the scale factor here is 2, which means it's greater than 1. So see how it's getting larger and larger and larger? Okay? Anyway, I thought this Geodura exercise was a nice way for you to see how it's changing. You can also play around with this. In your student guide, it gives you directions for creating this Geodura file. Okay, let me move this out of the way. Let's move on. Let's look at some examples here. It says, Chow has a digital photograph that is 5 inches by 7 inches. He wants to use his computer to make the picture into a thumbnail image that is 1 inch by 1.4 inches. What scale factor should he use to make the thumbnail picture? So what you're going to do is find the ratio of the image length. Okay? So remember, your image is your new one. Your pre-image is the old one. Your old one is 5 by 7. Okay? That's your pre-image. Your image is going to be the thumbnail. Okay? That's 1 by 1.4 inches. So find the ratio of the image length to the pre-image length. Okay? So my image length is going to be 1. My pre-image length is going to be 5. And I just went ahead and highlighted this to you for you. So you realize the thumbnail is the image, the digital photograph is the pre-image. Okay, so my image length, which is 1, over my pre-image length, which is 5. You'll always set up your fraction just like this with your image on top, your pre-image on bottom. So you have 1 over 5. Chow should use a scale factor of 1/5. You always reduce them as well, but this can't be reduced any further. Okay, this says describe the image of a figure under a dilation with a scale factor of 2/3. Okay. The image lies on the same side of the center of dilation as the original figure. And we know that because the scale factor is positive. Remember, if it's positive, it's going to be on the same side. If it's negative, it's going to be on the opposite side. We know the length of any segment in the image is 2/3 the length of its corresponding segment in the pre-image. Okay? That means it's going to be just a little bit smaller. Okay, this one says in the figure shown, the quadrilateral pre-image is shown next to its image. The image is the result of a dilation by a positive scale factor with a value greater than 1. Locate and label the center of dilation. My question is, how do you know which is the image and the pre-image? Well, if you look up here, it says it has a positive scale factor greater than 1. Okay? Well, that right there, since it's positive, tells us that both images are on the same side of the center of dilation. And since it's greater than 1, tells me that the image is getting bigger than the pre-image. Okay? So I just went ahead and labeled them. Here's my pre-image. My image is getting bigger. So the dilation by positive scale factor greater than 1. And again, I know they're going to be on the same side of the center of dilation because it's a positive scale factor. Now, what you do when you're looking for the center of dilation is see how these are corresponding corners of this quadrilateral right here. So what I'm doing is I'm just putting a line through those corresponding points. Watch this. I'm going to take this line and I'm going to put it through these corresponding points. All right. So pretty sure that this right here is my center of dilation, but what you need to do is put lines through all of the corresponding points. So here's my third line. See how I'm going through this corresponding point? And then here's my fourth line, going through these corresponding points. And so ta-da, there's my center of dilation. And look, they're both on the same side. Okay? This is classify each of the following as representing an expansion, a contraction, or neither. A life-size wax figure of a movie star. Well, if it's life-sized, it's not going to be getting bigger or it's not going to be getting smaller. So it won't be either of them. Okay? It'll be neither an expansion nor contraction. Okay, let's try a 4-foot by 6-foot poster made from a 4-inch by 6-inch picture. So you took a little 4 by 6 picture and you made it into an inch and you made it into a 4 by 6-foot poster. So since it's getting bigger from a little picture to a poster, that's going to make it an expansion. This is describe the effect each scale factor and center of dilation will have on a circle. Consider whether the dilation is an expansion or contraction and whether the location is relative to the center of dilation. Well, first, this problem says it's a negative 1/3. The center of dilation outside the circle. Okay, well, if I look at this negative, that tells me it's going to be on the opposite side of the center of dilation. And since 1/3, the absolute value of 1/3 is 1/3, that's smaller than 1, which tells me it's going to be a contraction. Okay, and I just included this table here. So if you go back and you look at the slides that I put in Dr. Sharing, you will be able to look at this and see how it works. It's a contraction. value smaller than 1, that means the figure's getting smaller, so it's a contraction. Okay, remember that's what it says over here. Absolute value less than 1, image is smaller. Okay? Then I put the images on the opposite side of the center of dilation from the pre-image. That's because it's negative. So if you look down here at negative, small absolute value, it's on the opposite side of the pre-image. Opposite side of the center of dilation of the pre-image. Okay, what we talked about today, a dilation is a transformation that preserves the shape but not the size of the original figure. Remember what I told you at the beginning, a dilation is not an isometry. The center of dilation is the point of intersection of all lines through their corresponding points on a pre-image and its image into dilation. And remember, dashed lines through the points on that touch block. The scale factor for dilation determines whether the image will be larger or smaller, and by how much. And it also determines whether the image lies on the same side or on the opposite side. And it is possible to sketch the image of a figure under a dilation given the center of dilation and the scale factor. And same old, when you get finished watching this video, you should read through the LMS lesson on dilation and scale factors. A lot of times they give you a little bit more detailed information than I give you in the video, so you need to be sure to read through those. And also complete the student guide, because remember, you get to use your notes on your quizzes and tests. Read the lesson and the reference guide, because they may tell you more stuff than I'm going to get in the video and now on this. Complete 1 through 19 odds in the problem set, and that's very important because that helps you do well on the quiz. After you get finished working those problems, contact me using Yahoo Messenger or go to Toga that day